All right, so today we're diving into something pretty interesting, I think. It's where formal logic gets really precise, but we're also dealing with these kind of messy complexities of language, right? Like, how do we talk about truths that are super specific, like tied to a particular moment or maybe a very particular possibility?
Yeah, yeah, exactly. And as philosophers, you're probably used to dealing with statements like, it is raining
Yeah.
in modal logic, pretty straightforward.
Right, right.
But what about something way more specific, like, it is 5 o'clock on November 15th, 2021?
Oh, yeah,
That kind of specificity, well, it brings in a whole new set of challenges logically.
it does. And that's kind of what we're going to be digging into today. So that's
Yeah.
the whole point of this deep dive. We're looking at these things called hybrid logics, and they were designed to tackle this exact problem, where regular modal logic just kind of falls short.
It does.
So we're going to be using some excerpts from the Stanford Encyclopedia of Philosophy, specifically their entry on hybrid logic.
Great source.
It's really good, yeah. It gives a really solid explanation of all this stuff. And the main thing we want to figure out is how hybrid logic actually gets this extra power, this extra expressiveness.
Mm-hmm.
And a lot of that comes from these concepts of nominals and satisfaction operators. Sounds kind of technical, but we'll break it down, I promise.
We will.
And of course, we got to talk about Arthur Pryor.
Of course, the pioneer.
Yeah, a real pioneer in the field.
Mm-hmm.
So our goal today, especially if you're a philosopher wrestling with these issues of, specific truth and stuff,
Yeah.
we want you to walk away with a good grasp of what hybrid logic is all about and why it might be something you want to add to your own philosophical toolkit.
Absolutely. It's a powerful tool, especially when standard modal logic just can't quite capture what you need to say.
Right. So let's dig into that a little bit. Why does standard modal logic kind of struggle with these super specific statements? You touched on that a bit earlier.
Yeah, so with ordinary modal logic, it's great at talking about possibilities, like what could be true, what must be true across different situations. But sometimes, a philosophical argument, it really hinges on something being true at a very specific point, like a particular event happening at a precise time or a unique entity existing in one specific possible world.
Mm-hmm.
And standard modal logic, it just doesn't have a clear way to express that kind of specificity.
Right. Yeah. Like it's almost as if you're trying to like pinpoint a location on a map.
Hmm.
And you can only talk about general regions like, oh, it's somewhere in this state, but you can't give the exact coordinates.
That's a great analogy. You need those precise coordinates for certain kinds of philosophical work.
Exactly. So how does hybrid logic give us those logical coordinates then?
The key innovation is this thing called nominals.
Okay.
Think of them like special labels, each one referring to just one specific world or point in our logical model. It's like giving each possible world its own unique name.
Okay. So it's like um, instead of just saying like a city,
Right.
we're saying New York City or London.
Precisely. So instead of a general proposition that could be true in many places, you have this nominal that's grounded, tied to just one specific spot.
I got it. Yeah.
And this is super useful if you're a philosopher thinking about, say, identity across different possible worlds, because now you can actually use these nominals to pick out and refer to those specific worlds directly.
Right. So instead of just saying, there exists a world where Socrates is a carpenter, you can be like, in world W1, Socrates is a carpenter.
Exactly. You're pinpointing that precise world where that specific fact holds true.
Right.
And that allows for much more precise discussion.
Okay, that's pretty cool. But we can't just label worlds, right? We need to say what's true in them at those specific points.
Right,
How
exactly.
do we do that?
That's where satisfaction operators come in. It's a way to express what's true at the exact point a nominal refers to.
Okay.
Usually written with an at symbol followed by the nominal, like at.
Okay. So for example, if we have the nominal T for, say, 5 o'clock on November 15th, 2021,
Okay, yeah.
and then P for the proposition, it is raining,
Mhm.
then at TP means at that specific time T, it is raining.
Oh, so the at symbol, it's like saying at this exact point in time, basically.
Exactly, you got it. And if you're, say, a philosopher working on temporal logic,
Yeah.
this gives you a really precise way to talk about what's true at specific moments in time.
Yeah, that makes sense. Now, the text also mentions something about the truth conditions for these satisfaction operators. What does that mean exactly?
It's just a formal way of saying when these statements are true.
Right.
So a nominal like A is true at a world, W if and only if A actually refers to that world, W, and a satisfaction statement like at F is true at a world, let's say W, again, only if the formula F is true at the world that A refers to.
Okay, so it's all about making sure everything lines up correctly.
Yeah, that the nominal is pointing to the right world and that whatever we're saying is true at that world. Okay, yeah, that makes sense. So it's kind of like with these at operators, we're essentially shifting our focus, like zeroing in on that specific world that
Yeah.
the nominal picks out.
Precisely. It's like you're ignoring everything else and just focusing on what's happening at that one particular point.
Gotcha. Now, I have to admit, this is where it starts to get really interesting for me, at least from a philosophical perspective.
Mhm.
The text mentions that we can actually use these tools, nominals and satisfaction operators,
Mhm.
to express identity between points.
Right. That's one of the really powerful things about hybrid logic.
Okay, so like how does that actually work?
So let's say we have two nominals, A and B.
Okay.
A refers to world W and B refers to world V. The formula at a B, what that's actually saying is that W and V are the same world.
Whoa, hold on. Walk me through that again.
Sure, so remember, at a B means at the world referred to by A, B is true. Well, A refers to W, right?
Right.
And for B to be true at W, that means B has to refer to W as well. But we said B refers to V.
Yeah, so for the whole thing to be true, W and V have to be the same.
Exactly.
Wow.
Rough.
So we're not just talking about worlds, we're actually using the logic itself to express the relationship between those worlds.
You got it.
That's pretty amazing. And then the text mentions that this ability to express identity, it leads to some other pretty important things like reflexivity, symmetry, and transitivity, all those core properties of identity.
Absolutely. Like if something is identical to itself, that's reflexivity. So in hybrid logic, at A, that formula is always going to be true.
Okay, yeah.
And symmetry, that's the idea that if X is identical to Y, then Y must be identical to X as well. In hybrid logic, that's captured by the formula at AB at BA. Always true.
I see.
And then there's transitivity, right? X is identical to Y and Y is identical to Z, then X must be identical to Z. And that's captured by at AB at BC, at EC. Again, always true.
So those aren't just some random formulas.
Yeah.
They're actually reflecting these really fundamental principles about what identity actually means.
Exactly. They show how those deep philosophical concepts are baked right into the structure of the logic.
Okay, that's pretty powerful. And then there's that thing called the rule of replacement. It was like at B,
Oh, yes, that's a key one.
which basically says if A and B are the same, then anything true of A is also true of B. Sounds a lot like Leibniz's law to me.
It is. It's essentially the same idea, but now formalized within the framework of hybrid logic.
Gotcha. Okay, so we've got these awesome tools now, nominals and at operators, that let us pinpoint specific worlds, say what's true in them, and even express identity relationships between those worlds.
Hmm?
But the text also mentions these things called binders, like the universal binder and the down arrow binder.
Yeah.
What do those do?
Those add another layer of expressiveness. They allow us to talk about all the points in our model in a more general way.
Okay.
So the universal binder, written LFR, it works a lot like the universal quantifier in, say, first-order logic. It's saying that for every possible point A could refer to, the formula has to hold true.
So if I say, like, AAP, that means the property P is true for literally every point in our model of possible worlds.
Exactly.
Okay.
Got it.
Okay, that's pretty powerful. What about that down narrow binder?
That one's a little different.
Okay.
So AAA, that's true at a world W if and only if the formula is true at that same world W. But when the nominal A is specifically assigned to refer to W, it's like saying in this very world.
So it's like a way to bring in the immediate context into the logical statement itself.
Yeah,
Yeah.
exactly. It's a way to kind of anchor the formula to the specific point where it's being evaluated.
Interesting.
And there's actually a cool connection between these two binders. AAA is equivalent to AAA.
Really?
Yeah, so saying in this world it is true is the same as saying for every world, if that world is this world, then ev is true.
Okay, wow. So in a way, this down arrow binder can be defined in terms of the universal binder. That's pretty neat.
It is. It shows how these seemingly different concepts are actually deeply connected.
Yeah, okay, so we've got these nominals, satisfaction operators, and now these binders. We can name specific points, say what's true in them, and even quantify over them. But all this, it feels a bit abstract still. How does this all actually work formally? What's the underlying, mathematical machinery of hybrid logic?
Right. So the formal semantics, the way we actually give meaning to these formulas, it builds on what's called Kripke semantics for standard modal logic.
Okay.
A model still has those three components: a set of possible worlds, W, an accessibility relation R between those worlds, an evaluation function V that tells us which propositions are true at each world. But now we add in this new thing, an assignment function, usually called G.
Gee, okay. What does that do?
So G basically connects each nominal to a specific world in W. It's what gives the nominals their, fixed reference.
Okay, so GA tells us exactly which world the nominal A is picking out.
Precisely. And then we define what it means for a formula to be true at a world under a given assignment. Pretty much like in standard modal logic, but with some extra rules to handle the nominals at operators and binders.
Okay, so let me see if I've got this right. The assignment function G is like the glue that holds everything together.
Yeah.
It connects the nominals to specific points in our model, and then all the truth conditions for propositions at, operators, binders, they all build from that.
Exactly. You got it. It's the foundation that makes the whole system work.
Okay, that makes sense. So can we see, like, concretely how this hybrid logic is more powerful than regular modal logic?
Yeah.
Especially for capturing distinctions that are philosophically important.
Absolutely. Let's take that formula we mentioned earlier. Item UC. It expresses irreflexivity, the idea that no world is accessible from itself.
Right. Yeah, that's a pretty important concept in a lot of philosophical contexts.
It is. Now, in standard modal logic, you can't actually express that directly, but with hybrid logic, you can. Because area C is only true at a world if, when C refers to that world, none of the worlds accessible from it are that same world.
Okay, so it's like saying in this world, there's no way to get back to this world by filing the accessibility relation.
Exactly, and that's precisely what irreflexivity means.
Okay, cool.
And there are other examples too, like asymmetry, antisymmetry, even the idea that every world is accessible from every other world. Hybrid logic can express all these things that standard modal logic just can't.
So having these nominals, these specific labels for worlds, it really gives us a much finer level of control over what we can say about the structure of possibility.
Exactly. It allows for a much more nuanced and precise analysis of these modal concepts.
Okay, now I'm curious about something else. The text mentions a connection between hybrid logic and first-order logic. What's that all about?
So it turns out you can actually translate hybrid logic into first-order logic with equality. Then vice versa, you can translate a good chunk of first-order logic into hybrid logic.
Wow. So these two, like, really powerful logical systems, they're actually kind of intertranslatable?
Yeah, in a way, it shows there's a deep connection between them.
Okay, but how does that translation actually work?
So in first-order logic, we have predicates and variables, right? Well, in this translation, we treat the nominals from hybrid logic like variables in first-order logic. And these variables, they stand for possible worlds.
Okay, so like each nominal gets turned into a variable that ranges over worlds.
Yeah, exactly. And then we have predicates for things like the accessibility relation and whether a proposition is true at a world. So, for example, the hybrid logic formula at a world A, that gets translated into something like, for all worlds B, if B is accessible from A, then S is true at B.
I see. So it's like we're spelling out all the modal stuff in terms of quantifiers and relations between worlds.
Exactly. We're making explicit what was kind of implicit in the modal language.
Gotcha. And the text even showed how that formula for irreflexivity, ERO-C,
Yeah.
that gets translated into a first-order formula that literally means no world is accessible from itself.
Right. So it's a concrete example of how hybrid logic can capture these first-order properties.
Okay, so it's more than just a theoretical possibility. It actually works out in practice.
Exactly.
And what about going the other way, translating from first-order logic to hybrid logic?
You can do that too, but it often requires using that universal binder from hybrid logic to capture the full power of first-order quantifiers.
Okay, so there's a bit of a trade-off there,
Yeah.
depending on which direction you're going.
Right.
But the main point is that these two logics, hybrid and first order, they're not completely separate. They're actually deeply connected.
Yeah, and that connection, it gives us a lot of insight into what both logics are capable of expressing.
Okay, yeah, that's pretty awesome. Now let's talk a bit about Arthur Pryor, the guy who really got this whole hybrid logic thing started.
Yeah, definitely got to talk about Pryor.
What were his philosophical motivations for developing these new logics?
So Pryor was super interested in time, the philosophy of time. He wanted a really rigorous way to formalize how we talk about the past, the present, and the future.
Okay, yeah, that's a classic philosophical problem.
Yeah.
So he was basically trying to create a logic of time.
Yeah, exactly. He called it tense logic. And instead of that box operator from standard modal logic,
Hmm.
he used operators like G for it will always be the case, and H for it has always been the
Oh,
case.
okay, so G is for the future and H is for the past.
Exactly. And these were all interpreted in terms of this earlier, later relation between moments in time.
Makes sense. So how did hybrid logic fit into all of this?
Well, Pryor had this really ambitious goal. He wanted to show that tense logic could be just as powerful as first-order logic when it came to talking about time. He even laid out these 4 grades of tense logical involvement with the idea that each grade added more expressive power. And his ultimate goal was to get to a point where tense logic could do everything that first-order logic could do with time.
Whoa, that's a pretty bold goal.
It was, and hybrid logic was the key to achieving it. Pryor realized he needed to be able to talk about specific moments in time, just like we were talking about with those nominals.
Right, yeah, so he needed those precise coordinates for time as well.
Exactly. He called them instant propositions. And he also introduced the universal binder and satisfaction operators into his tense logic. And with all that in place, his 3rd-grade tense logic became essentially equivalent to hybrid tense logic.
Wow, so he actually managed to pull it off. He made tense logic just as expressive as first-order logic.
In a way, yes. He showed that you could, in principle, express everything you could say in first-order logic about time using this enhanced tense logic.
That's amazing.
Yeah.
But the text did mention some philosophical debates about all of this. What were those about?
Yeah, so the main debate was about what all this meant ontologically.
Ontologically?
Yeah, like what does it tell us about what exists, about the nature of reality? Some philosophers argued that Pryor's use of that universal binder, it implied that we had to accept these individual moments in time as real, concrete things.
Because we were quantifying over them.
Right. And some people felt that this was too much of a commitment, that maybe we shouldn't have to say those moments actually exist in order to talk about time.
Okay, yeah, I can see how that could be a problem.
It gets into some really deep questions about the nature of time and how our logical systems relate to reality.
Yeah, definitely. The text also mentioned that Pryor, while he gets credit for hybrid logic,
Mm-hmm.
there were actually some hints of these ideas in his earlier work.
Yeah, it's pretty interesting. Later scholars went back and looked at Pryor's writings and found these like little seeds of hybrid logic sprinkled throughout.
Oh, so he was already kind of playing with these ideas before he formally developed hybrid logic.
It seems that way. And there are also some great biographical works on Pryor that give a lot more context to his philosophical development and how these ideas came about.
Well, it's really cool to see how this deep philosophical thinking about time led to this whole new logical system. And it didn't stop with Pryor, right? Hybrid logic, it kept evolving after him.
Absolutely. It really took off, especially in the last few decades.
So what were some of the big developments after Pryor?
So one important step was making the definition of hybrid logic more rigorous, more formal. That was done by Robert Bull in 1970. He introduced this idea of sorted propositional symbols, where different kinds of symbols have different rules for how they can be interpreted.
Okay, like different categories of propositions.
Yeah, exactly. It's a way to add more structure and fine-grained distinctions to the logic.
Got it.
And then in the 80s, you had Passy and Tinchev. They both independently rediscovered hybrid logic.
Rediscovered.
Yeah, but in a different context. They were working on something called propositional dynamic logic, which is used a lot in computer science to reason about programs.
Oh, interesting. So hybrid logic popped up in a completely different field.
Yeah, it shows how versatile these ideas are.
Okay, cool.
But probably the biggest development was the introduction of that down narrow binder, the O, in the 90s.
The one we talked about earlier.
Yeah, that one. It was formally introduced and studied by Blackburn and Seligman,
Yeah.
and it really opened up a whole new area of research in hybrid logic.
So with this new binder, people could really start exploring the connections between context and truth in a much more formal way.
Exactly.
Now, all this sounds pretty complicated. Is hybrid logic, like, computationally expensive to work with?
It can be, but one really interesting result is that even without those binders, just using nominals and satisfaction operators, the logic is still decidable. Meaning, there's an algorithm that can tell you whether any given formula is satisfiable or not.
Okay.
And the cool thing is, this binder-free hybrid logic, It's no harder to decide than regular modal logic.
Wow, so you get all this extra expressive power without making the logic fundamentally more complex.
Yeah, it's a pretty remarkable result.
Okay, so hybrid logic has all these connections to first-order logic. It's got this fascinating history, and it's computationally tractable.
Hmm.
But how do we actually use it?
Right, so for that, we need proof systems,
Yeah.
ways to actually derive conclusions from
Right,
premises.
like how do we know what follows from what?
Exactly. And thankfully, there's been a lot of work on developing proof systems for hybrid logic.
Oh, good.
One important concept here is that you can create a proof system that's specifically tailored to certain kinds of frames, those models of possible worlds. So you start with a basic set of axioms, and then you can add in special pure formulas where all the propositions are actually nominals. And the resulting system, it'll be sound and complete for exactly those frames that validate those pure formulas.
So it's like we're customizing the logic to fit the specific kind of modal structure we're interested in.
Exactly. Like if you want to reason about frames where no world is accessible from itself, you can add a specific axiom for that.
Okay, that's pretty cool. It's like we're building the logic to fit the metaphysics.
Yeah, exactly. And there are different kinds of proof systems too, like Tableau systems, Gensen systems, natural deduction. And one of the nice things about hybrid logic is that these proof systems tend to be more uniform, more general than for standard modal logic.
Okay, so they're easier to work with.
In a way, yeah. Like you can often use the same basic system for lots of different hybrid logics without having to make big changes.
Okay, so there are all these tools and techniques for actually doing hybrid logic, not just talking about it abstractly. What about quantified hybrid logic?
Ugh, that's where things get even more interesting. That's where you combine hybrid logic with full first-order quantification, like in predicate logic.
Oh, wow. So now we can talk about objects and properties in those different possible worlds, not just the worlds themselves.
Exactly. It adds a whole new level of expressiveness. But of course, it also comes with some added complexity.
Right. First order logic is already pretty complicated on its own. But is there anything like particularly noteworthy about quantified hybrid logic?
Yeah, so one big thing is that it has something called interpolation theorems.
Interpolation theorems, what are those?
They basically say that if you can derive a conclusion from a set of premises, then there's a kind of intermediate formula that captures the information that's relevant to that conclusion, using only the language that's common to both the premises and the conclusion.
Oh, so it's like a way of like extracting the shared information between statements.
Yeah, exactly. And this is something that some standard first-order modal logics don't have, so it's a nice feature of the quantified hybrid logic.
Okay, so it behaves a bit better than some of its cousins in that regard. What else has been done with quantified hybrid logic?
Well, there's been work on like hybrid versions of higher order modal logic where you can quantify over not just objects and properties, but also over like sets of properties and so on.
Oh, wow. So it's like logic on steroids.
Pretty much.
And Pryor's alternative method for creating nominals using propositional quantifiers has also been studied further, right?
Yeah, that's right. And it turns out there are actually some subtle differences depending on how you interpret those propositional quantifiers. It gets into some really deep questions about the nature of possibility and what it means for something to exist in a possible world.
So even within hybrid logic, there's still this like ongoing exploration of the fundamental concepts.
Oh, absolutely. Hybrid logic is a really active area of research, and there's still so much to discover.
Well, that's probably a good place to wrap up. So for our listeners, especially those of you who are philosophers looking for new logical tools, we've seen how hybrid logic takes modal logic and supercharges it by adding nominals and satisfaction operators.
Exactly. Those tools give you the power to talk about specific worlds, specific moments in time, and really pinpoint where certain truths hold.
And we talked about Arthur Pryor, the pioneer of this whole field, and his really ambitious goal of making tense logic just as expressive as first-order logic when it comes to talking about time.
Right, and he achieved that goal in a very elegant way by introducing those hybrid logic elements into tense logic.
And we've seen how hybrid logic is connected to first-order logic, how it's computationally tractable, and how there are all these really neat proof systems for working with it.
Absolutely.
So it's not just a theoretical curiosity, it's actually a really powerful and practical tool for analyzing all sorts of philosophical problems.
For sure.
Now, for a final thought, think about what it means to be able to refer to and reason about individual worlds or times in such a precise way. How does that change our understanding of modal and temporal reasoning? And are the objections that some philosophers raised against Pryor's approach, are they still valid given all the advancements in hybrid logic since then?
Those are great questions to ponder. And, what new philosophical doors might this powerful logic open up for us? It's a really exciting field, and there's still so much to explore.
Absolutely. And on that note, we'll end our deep dive for today. Thanks for joining us.
Thanks for having me.